Hi, I'm Frank Lamb with Automation Consulting, and this is the Omron CJ2M Odyssey project. In this video, we'll be covering the following topics. This is the trainer that we're going to be using. This has a CJ2M CPU 31 processor. It has 3 communications ports, USB for our programming, serial, which is usually used for the HMI. Here's an Ethernet IP port. There are 3 additional cards. There are 16 DC inputs, 16 DC outputs, and a combination 4 input, 2 output analog card. Here is the power supply, the CPU. There's a DC power supply here for I/O, various push buttons, pilot lights, and potentiometers. And we'll be making our way through using this demo and setting up the I/O here. In these videos, I'm going to start a project in Omron CX Programmer. The Omron folder down here contains several different objects. There is a server, which includes driver management tool and import-export. The CX1 folder also includes all of these directories, including CX Designer, some motion control programs down here, CX Programmer, which is what we're going to use to write the Omron program and download it, a CX simulator, so we can simulate our programs, and we're going to explore all of these things. To begin, I'm going to go ahead and open up the CX Programmer software. As you can see, this is version 9.7. And you can see your typical layout for PLC programming software. This is all integrated into one package, unlike Siemens. We'll create a new project here. Of course, as with all PLC programs, you have to pick the processor first, and we are going to be using a USB driver to go into the front of the controller, and we'll give it a nice name here. I'm going to call it Odyssey. As with all PLCs, the first thing we need to do is configure our I/O, which is in here in the I/O table and unit setup. Now to start with, I selected a CPU 11, and we're going to change this processor by going into the settings here from a CPU 11 to a CPU 31. And of course this makes the processor a little bit bigger. Now in the main rack, we're going to add a unit here, basic I/O, and this is an ID 211. I've written down the part numbers here on a piece of paper. That's always a convenient way to do your organization. You can see it's a 16-point card. I'm going to put a 16-point output card in the next slot. That is an OD212, all in alphabetical order here. 16 points. And then in the third slot, we have an analog card. So this has 4 points and 2 outputs, 4 input points and 2 output points. The address of this unit, it has little set points here on the front of the analog card. And both of these dials are set to 0, so that's what we're going to make this is unit 0. There are further settings that you can make for every input and every output. You can change what type of input it is. In this case, it's 0 to 10 volts, so that's where we're going to leave it. And that should finish up the configuration of all of our cards here. Now that we've configured the hardware, we're going to need to give the CIO data area some names for some of the different inputs and outputs. These are the different memory areas that we're going to be using in this project. You can see here the first one listed is the CIO area, and this is all the inputs and outputs that we just configured in the hardware. There are also bits here for the work area, the holding area. The difference between those areas are the work area is non-retentive and the holding area is retentive. The auxiliary area holds bits to monitor the PLC operation itself. They're pretty much read-only bits. There are a little bit of read-write memory in here also. This temporary relay area holds bits that record the on-off status of the program branches, and they're only used with mnemonics. The data memory area is kind of a multi-purpose data area, and it depends on the CPU type as how much you have. It may only be accessible in whole words. And they retain their content when the PLC's on, or if the operating mode is switched between program and run. And then there's an extended memory area here, and there's the data for the timers and the counters. The task flag area corresponds to the cyclic tasks, which are the different sections of the program that are running. The index registers are for holding PLC memory addresses, and then the data registers are used with the index registers. The first thing I'm going to do here is put a little bit of logic in here and give the addresses some symbols to start the symbol table. And to do this, I'm going to put a contact in here and use the first input address and give it the name PB1, which is push button 1 on the trainer. I'm going to put an output coil here, and we're going to use 1.00, which is the first pilot light. So here I'm in monitor mode. I'm pushing push button, but the light is not coming on in the demo. This is one of the confusing things about Omron. If you haven't downloaded, you can still monitor your logic. At this point, I'm going to transfer everything to the PLC. You can check all of these options. And it puts the processor in stop mode. And transfers everything. We're back in monitor mode here. And now when I push the button, the light does come on the trainer. So I'm now offline, and what I did was go in and edit the input and output that I used to test my download push buttons and indicators. So you can see here that my name is PB1 and my description is push button 1. My name is indicator IND1 and my description is indicator 1. So I'm now going to edit this and put in all of the other push buttons and switches and indicators. To add symbols, just use this insert symbol icon. And of course you can copy and paste and then rename things. Now just to make things a little bit easier, I went up here into my symbols reusable file and I did a save as in a directory where I know where it is, and I saved it as symbols, and that comes across as a CXR file. What it looks like if you open it in Notepad is like this. And this makes it easy to copy a line like this and paste it underneath and then edit it. So it's sometimes easier to do your editing in another application such as Excel or Notepad and then paste back into the application. And this would have been easier in Excel. You can copy and paste from pretty much anything. And once again, we're going to paste all of these back into the application. And you can see how this works. So the symbol editor is not all that user-friendly. I would suggest, if you were doing this on a large scale, doing it in Microsoft Excel. So at this point, we have completed our symbol table and we're ready to start writing the program using these symbols. As we create additional symbols, we'll probably create them on the fly as we go and just name the contacts. And that is the end of this video. Thank you very much.